Welcome to another video. Let's solve a mixture problem. Now, whatever you see in this video is what you would get in every problem that has to do with mixing. Sometimes they say it is salt dissolved in water, sometimes, and that's what you call a brine solution. It's salt dissolved in water, and sometimes it is detergent, sometimes it is alcohol, like this one. Whatever it is, as long as you're doing a mixing in a tank and you're adding and you're either subtracting or not subtracting, it doesn't matter. Just follow whatever you see in this video and it will be easy for you to get your answer. The most important thing is that you're able to make a sketch like this from the information. So what we're going to do is use the information. I already made this because I want to save time, but you're going to see how relevant you can just pick the information and use it. And there are only 3 parts to every question. What is coming in, what was there at the beginning, and what's going out. Now, it could get more complicated depending on how many things are coming in and how many holes you have that are going out. That's where it gets crazy. But this one is just the standard one, and it's a good way for you to have an understanding of what happens in a mixing problem. Let's get into the video. A tank contains 50 gallons of a 10% alcohol solution. A second solution containing 50% alcohol is then added to the tank at 4 gallons per minute. As the second solution is being added, the tank is being drained at 5 gallons per minute. How much alcohol is in the tank after 10 minutes? The first thing you want to think about is, how did we start? We started with a 50-gallon tank that is 10% concentrated in alcohol. So let's just use the term concentration. So this is 10% concentrated. Sometimes they give you things like, oh, it is 5 grams of salt dissolved in it. Just use that, okay? Just whatever they give you, use it as the number that you're going to be using. So I'm just going to use the percents as the numbers, as the concentration. So now observe, let's say this part is sealed. This is just 10% alcohol in it. But this guy coming in is bringing in 4 gallons per minute, and what is coming in is 50% alcohol. So that simply means you're getting it more and more concentrated. There's more alcohol coming in. But while this is coming in, you're taking out the mixture at 5 gallons per minute. So firstly, just look at, because this is how you want to start. The rate at which liquid is coming in is slower than the rate at which liquid is going out. So you should envisage in the long run, you're going to have less and less and less volume in the tank. And after a while, you're going to drain the tank completely. Right? Yeah, it makes sense. Okay, so because you started with 50, you're bringing in 4 every minute, but you're taking out 5 every minute. It's like a bank account. The more you take from it, the faster it drains. So this is going to drain eventually. Okay, that's one important thing. So what do you need to know? You need to know that what you're solving for is the amount of alcohol in the tank. Whatever question you're given, it is the amount in the tank at a given time is what you're looking for. So let's just start and say, let y as a function of time be equal to amount of alcohol in tank at time t. This is the most important thing in all of this thing you're doing, this mixing. How much alcohol is in the tank at a given time? So let's do a quick test. How much alcohol is in this tank when t is equal to 0 at the very beginning? 10% of 50 gallons. What is 10% of 50 gallons? 5 gallons. So you got 5 gallons of alcohol sitting inside that tank at the beginning. Okay, so now let's keep going. Now, the next thing you want to ask yourself is, how much alcohol is coming in? Well, that one is a bit tricky because it's not like they dumped it at the same time. No, it is coming in per minute. 4 gallons every minute. 4 gallons every minute. So the amount of alcohol that's coming in is that every minute you got 4 gallons and 50% of that is alcohol. So what's 50% of 4? 2, right? And how did I get it? I just multiplied. I just did 50% of 4. I got 2. So 2 gallons of alcohol is coming in every minute. That is what you call the rate in. Rate in equals inflow rate times inflow concentration. So that's what I did there. 50% of everything that comes in is alcohol. So it is the concentration multiplied by the inflow rate. That is the rate in. And we can easily do that. What is that number now? Inflow rate is 4 gallons per minute. What is the inflow concentration? 50%. So that means 50% of this is going to give us 2 gallons per minute. This is equal to 2 gallons per minute. To help you, I think you should just retain all the units. Make sure you show them. Let's go to the next one. So how much alcohol is going out from here? Well, it is basically the same formula. Outflow rate times outflow concentration. Let's write it. What is the outflow rate they gave us? It's 5 gallons. 5 gallons per minute. What is the outflow concentration? Remember, what you're taking out is what has been mixed up in here. We don't know it. We know this one. It's 50%. We know what was there at the beginning. But as soon as you start adding and you start mixing stuff, we don't know what the concentration of this guy is. So at the factory, that's where the problem is. Because they need to follow the standards of manufacture. So they have to know what the concentration of what's coming out is. What exactly would it be? We have to think about it. And this is the hardest part of this. Okay, just pay attention. Concentration is basically how much alcohol is in this thing compared to the total amount. You see, we had this, we said 10% of this was alcohol, which was just 5, right? 5 gallons of this was alcohol, or 5 liters. It doesn't matter what unit you pick, just keep that unit. It is the amount of alcohol divided by the total volume of solution. So we can actually call this amount of alcohol divided by volume of solution. That is how we get whatever concentration. That's the formula for concentration. If this was salt mixture, it would be amount of salt divided by volume of solution. That's how you do all concentrations, okay? Now, what is the amount of alcohol in the tank? Like I said, at the beginning we knew it was 5. But at any time, we don't know what it is. And that's the hardest part. If you get this explanation, everything else is easy. The volume of the solution, at the beginning, it was 50. So after 1 minute, we had put in 4 gallons. So the total coming in plus what was there became 54. But at the same time, we had drained 5 gallons in 1 minute. So 54 minus 5 gallons is going to be 49. After 1 minute, you already lost 1 gallon because you're draining more than you're bringing in. So the 1 gallon you lost is actually the difference between the inflow rate and the outflow rate. That's the gallon that you're missing. So at time t, you have lost t gallons. At 1 minute, you've lost 1 gallon of the total. At 2 minutes, you've lost 2 gallons. At 3 minutes, you've lost 3 gallons. So basically, the amount that is left is 50 minus how much time has passed. Make sense? And this is what is responsible for it. So here we can say this is equal to 5 gallons per minute multiplied by the amount of alcohol in the tank. Remember, we still don't know. But we know what the volume is going to be after t minutes. The amount of alcohol in the tank is this. The amount of alcohol in the tank at any time is yt. So this is going to be y as a function of t, and it will be divided by the volume of the solution that is left in the tank, which is basically what was there originally minus the difference, because this guy is draining this guy faster. If this was faster than this, then the tank will be filling more. But because this is faster, it's draining it, so it's going to be just minus t. So instead of you doing 50%, well, we're just going to say percent. We don't know what percent that is. Okay, so now that this explanation is, because like I said, this is the hardest part. Now listen to me. Pay attention. If the rate of inflow was the same rate of outflow, we will not need to subtract anything. This would just be 50. Okay, we will not need to subtract anything. And if the rate of inflow was greater than this, we'll be adding. Whatever you see as the difference between the inflow and outflow, that's what affects this one. Okay, let's go back to the main problem now. So what's now going on? What's going on? What's going on? We have said the rate at which alcohol is coming in is 2 gallons per minute. The rate at which alcohol is going out is this. We couldn't figure out the full formula for this, but we can actually rewrite it nicely. 5 times y is going to be 5y over 50 minus t. So now this is the rate at which alcohol is going out. Okay, per minute. So what is the rate at which alcohol is accumulating in the tank? It is the difference between what is coming in and what is going out. Rate of change of alcohol amount is what you call the rate of change of amount of alcohol with time, dy dt. dy dt is the rate in, dy dt is the rate at which you're gaining, rate in, right there, minus the rate out. I think I use caps, so let's do this. You're gaining rate in minus what you're losing. That's the rate at which your money is changing. Don't spend your money anyhow. Now, what is the rate in? We calculated it to be 2 gallons per minute. So it is 2 gallons per minute minus what is the rate out? We just found it to be 5y over 50 minus t. And that's our dy dt. That's dy. So this is the mission. Solve dy dt. In fact, because looking at this, let's write it. Solve dy dt equals 2 minus 5y over 50 minus t. If you solve this differential equation, you're going to get the amount of alcohol in the tank at any time, including at the beginning. I don't know if this is separable. It's not looking like it's separable. And if it's separable, I don't think it's going to be interesting. I think I would rather treat it as a linear differential equation. So I'm going to pull this over here and say that I'm going to rewrite this as y prime. Write it as y prime. Pull this over. It's going to become plus 5 over 50 minus t times y will be equal to 2. That my integrating factor, so my mu is going to be equal to e, which is 5, the integral of 5 over 50 minus t dt. So if I can integrate this, and that's all I need. I just need my mu. Now, what's the integral of this? I'm not going to use space for this. How do we integrate this? Pull out the 5. 5 times the integral of 1 over 50 minus t dt. If you integrate this, it's going to be natural log of 50 minus t. And this minus is going to come here to meet this 5. We can actually rewrite this by moving this up here, and it becomes the natural log of 50 minus t raised to power negative 5. So that when I bring it back on top of e like this here, it's going to get rid of this, and all we have is just 50 minus t to the negative 5. So this is what the integrating factor helps us achieve. Whatever you get as your integrating factor becomes your answer on the left-hand side. So it's going to be y. It's going to be 50 minus t raised to negative 5 times y. That's just it. Will be equal to the integral of this multiplied by this. So it's going to be, this is the right-hand side. So it's going to be 2 times 50 minus t raised to power negative 5 dt. You just use the integrating factor to multiply the right-hand side, and you integrate it, and you keep the product of this and this on the left-hand side. That's it. There's no more work. If we integrate this using u substitution, we're going to end up with, there's going to be our u, and this u to the negative 5th will become u to the negative 4th divided by negative 4th, and minus this. Do that on your own, okay? You're going to end up with, I think this is going to be 1/2 of 50 minus t to the negative 4th. Yes, and so you have 50 minus t to the negative 5 times y. So we can easily isolate y here. If you divide both sides by this is going to end up being 50 minus t raised to power 1. That's going to be 5 minus 4. And here it's going to be plus c times 50 minus t raised to power 5. That's what we're going to have. So now we need to find what c is. And these are the initial conditions. When t equals 0, y is 10% of the 50 gallons, so it's just 5 gallons like we said initially. So we're going to plug in these numbers here. T is 0 and y is 5. So initially, initial y, let me put it this way. Okay, the initial y is 5, so we don't need to write that. 5 is equal to, this is going to be 1/2 of 50 minus 0 plus c times 50 minus 0 raised to power 5. Okay, what does it look like? This is 5 is equal to, let's get c. So if we move this here and then we divide, we're going to have, so that's our solution. We found our c rather. So now we go back here and plug everything in. We say therefore y at time t is equal to 1/2 of 50 minus t plus, what is c? Negative 20 over 50. So that's going to be, so this is going to change to negative 20. So it's going to be minus 20 over 50 raised to the c raised to the 5 times 50 minus t raised to power 5. Huh, interesting. Now, do I want to factor? I'm just going to leave it that way. So what is the mission? To find how much alcohol will be left in the tank after 10 seconds. I just need to plug in 10 everywhere here and get my answer. So we have after 10 minutes. Y of 10 is going to be 1/2 of 50 minus 10 minus 20 over 50 raised to power 5 times 50 minus 10 raised to power 5. Y of 10 is going to be, this is going to be, what is that? 40 divided by 2, that's 20. So that's going to be 20 minus, let's leave this alone. Let's go here. This is going to be 40 raised to power 5 divided by 50 raised to power 5. Okay, that's easier, times 20. So I'm going to write it as 20 times, this is 40 raised to power 5 divided by 50 raised to power 5. That's 4 over 5 raised to power 5 times 20. 4 over 5 raised to power 5. Nice. I can pull out the 20. So this is 20 into 1 minus 4 over 5 raised to power 5. Setting up the equation was the biggest part of it, and I'm glad that I'm through that. This has been a long video. Never stop learning. Those who stop learning, stop living. Bye-bye.